stable product. Now, so in the mechanism of electrophilic addition reaction, it is like the pi electron cloud of the unsaturated hydrocarbon, that is alkene or the alkyne, attacks on the electrophile, forms a carbocation. This carbocation, if at all required or if at all possible, will undergo rearrangement to stabilize itself so that it can form a stable product. So once the carbocation is stabilized, now what will happen is the nucleophile attacks on the carbocation. The question which you can have in your mind now is that in this reaction electrophile is added as well as a nucleophile is added, but we are saying this reaction as electrophilic addition. Why not nucleophilic addition? So the reason for this is like the first step of the mechanism, that is when an alkene attacks on the electrophile, this is a slow step of the mechanism, and when the nucleophile attacks on the carbocation, that is a fast step of the mechanism. Now because the slow step of the mechanism involves the addition of the electrophile, that is why this reaction is an electrophilic addition reaction. If we write down the rate law equation for this mechanism, it will be rate equals to rate constant, that is K, into concentration of substrate, that is a unsaturated hydrocarbon, which can be either alkene or alkyne, into the concentration of the electrophile. So from the rate law equation itself, we can clearly see that this reaction is bimolecular, as well as it follows second order kinetics. Now one more question over here is that why the first step, that is when electrophile is being added in the compound, is a slow step of the mechanism. Why not the second step? There are two reasons behind it. First, the type of the compound actually will tell you whether the addition of the electrophile in that particular compound will be easy or difficult. Suppose around the pi electron cloud, we have a steric hindrance, then it will form easily carbocation, because the degree of the carbocation formed in that case will be the higher, and so the stability will also be high. Now the second reason is the reagent from where the electrophile is coming. Likewise, like we have in HX, it is basically the strength of the HX bond that will decide the rate of the reaction. In the HCl, as I told you that in HCl the bond length is short, so the force of attraction between H and Cl will be high, and therefore Cl minus will not leave HCl easily, or the cleavage of HCl bond is not that easy. Similarly, if we see for suppose HI, in this case I minus is a good leaving group, because the size of the I atom is very large, due to which the bond length of HI is large, and hence the bond dissociation energy of HI will be small, and therefore I will leave easily, and so the reaction becomes faster. So these are the two reasons which actually decides whether the reaction has to be slow or fast. Because in the second step, once the carbocation is stabilized, then the nucleophile will add to the carbocation with the equal ease, be it the case of HBr or HI or HCl. It won't make any difference.